In this lesson, we're going to learn about solving a triangle, and it'll be a non-right triangle. And we're going to, when we say solving the triangle, we mean we're going to solve for all of the remaining side and angle measures. So we're going to determine which formula you use by studying the pattern of the given measures. The patterns that you use are going to be the same patterns that you use to prove triangles congruent in geometry. The possible patterns for your given information will be side, 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 that is, all three sides are given to you. Side, angle, side, that is, two sides are given to you and the angle in between those sides. ASA, two angles and the side in between. AAS, two angles and the side not in between them. And SSA, finally, is two sides and the angles not in between them. All right, so in example 1, we're going to label the sides and angle for each of the triangles and identify the pattern of givens. Remember that side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So in this triangle, two sides are given and the angle where those two sides meet is given. That's a side angle side. In B, we have side A given, angle A, and angle C. This is an angle side pattern of givens because the two angles are given and the side not in between those two angles. In C, we have sides A, B, and C given. Since three sides are given, this is a side, side, side pattern of givens. In D, we have two sides and an angle. What's important to realize here is that the angle that's given is not the angles where the two sides meet or the angle in between the two sides. So this is an SSA pattern of givens. You may remember something special about SSA from geometry. You cannot prove two triangles are congruent using two sides and the non-included angle. Remember what that spells backward. The important thing about this is to realize is this is a special case called the ambiguous case, where we may be able to get more than one answer. In E, we have a side and two angles given. The side is the angle that where the two, the side is in between the two angles. So this is an angle side angle pattern of givens. In the last example, we have a repeat of D. So this is side side angle. In example 2, we can solve a proportion, which looks like the law of sines, and then we're going to solve it using inverse sine. First, we'll cross multiply, then divide by 6. Then we'll take the inverse sine. A note about solving these: don't reach for your calculator until you've solved for the unknown. It's important that we keep all of the exact form in the answer so that rounding doesn't happen if you write down intermediate answers. That is, don't reach for the calculator until you've solved for angle P. So now we're ready to put this in the calculator. Remember to use the sine inverse, and then inside the parentheses use control divide to get a fraction template. And this will give us 72.933. This is an approximate answer, but we'll use equal because it's accurate to 3 decimal places. And then we're going to show that the supplementary angle is also a solution. The supplement can be found by subtracting 180 minus that answer. And I'm going to use the answer key on my calculator, which is sec control negative, and that'll get us 107.067. In order to show that this is also a solution, we're going to replace P with that number, and I typed into my calculator sine of that number over 10, which is the left side of the proportion that we solved, and I got 0.096. Now we'll type in the right side. Sine of 35 degrees over 6 also gives us 0.096, so that shows that this is also a solution to the proportion. The reason for this is that the two angles, one in the first quadrant and one in the second quadrant, have the same sine value, since sine is positive in both the first and the second quadrant, that is, angles between 0 and 90, and their supplements, which would be between 90 and 180. In example 3, we're going to use the inverse sine to solve for angle V. First, we'll cross multiply, then divide by 4, then take the inverse sine. Now let's enter this into the calculator, and you'll notice that your calculator gives you an undefined result. The reason for this undefined result is that the inside of the inverse sine is a number that's greater than 1. Remember, sine is the ratio of opposite over hypotenuse, and if the opposite side is bigger than the hypotenuse, then that ratio will be greater than 1. So inverse sine of that will not give us a defined result. All right, now if we were going to solve anything with the pattern of givens, ASA or AAS, then there's only going to be one possible solution, and we can use the law of sines to find that solution for the triangle. In the SSA pattern, there will be a possibility of 0 solutions, 1 solution, or 2 possible solutions, depending upon how it's set up. When we solve for all measures of a triangle, it's important that you don't round intermediate results, because that can result in a loss of accuracy. For that reason, we're going to store solutions, and we can also sometimes use the answer feature as well. I want to show you how to store a solution. If we want to store a solution like 7, I'm just going to type 7 into my calculator. Then I'm going to press the Control key and the variable key, which has the word STO above it for store. And then I'm going to follow that with the letter that I want to store it in. So I'm just going to type the letter A and then press Enter. And now every time I press the letter A, it's going to think that I mean the number 7. So if I type 5 times A into my calculator, it will give me 35, because it'll go ahead and do that calculation as if A were 7. All right, in example 3, we are going to sketch a triangle, identify the pattern of givens, and then solve the triangle. We can either state that there's no solution, find 1 solution, or find 2 solutions, depending upon the pattern of givens. We're going to round every answer to the nearest thousandth if necessary. And a hint, do the easiest calculations first. And you'll see what I mean in this first example. So let's sketch triangle ABC with the given measures. And as you label these, remember that side B is always across from angle B. Now let's look at the pattern of givens. There are 2 angles and 1 side given, and this side is not in between the 2 angles. So this is an angle side pattern of givens. That means that we're going to use the law of sines. Before we use the law of sines, let's find the easiest part of the triangle that can be found using a very simple calculation. If you have 2 angles, go ahead and find the 3rd angle first. Measure of angle A can be found by subtracting the 2 given angles from 180. So let's do that calculation, and we will get a result of 78. We've solved for the 3rd angle. Now all that remains are 2 sides. We have 1 pair of opposite angle and side, and so they can be used as 1 side of the proportion in law of sines. And then I just picked 38 degrees, and let's find its opposite side, C. So setting up the law of sines, we can cross multiply and then divide by the sine of 64 degrees. And then this can be entered into the calculator for a result of 6.165. Now we can set up the law of sines to find the 3rd side, which would be side A. We can use the same ratio, sine of 64 over 9, that we used in the first proportion, and then the other side will be different, containing the opposite angle A and side A. Cross multiplying and dividing by the sine of 64, we can enter this into the calculator for a result of A equals 9.795. And now that we found the other three pieces of the triangle, that is, now we have the three given pieces, two sides and an angle, and we found the third angle and two remaining sides, we've solved the triangle. In B, we have triangle XYZ, angle X with angle X, side Z, and side X given. This is a side-side angle. Since the angle is not where the two sides meet, or the angle is not in between the two sides, we're still going to use the law of sines, but this will be an ambiguous case, meaning we may get 0, 1, or 2 solutions. Let's set up what we can with the law of sines. We have one pair of opposite angle and side, which we can set equal to another pair of opposite angle and side, so we'll have to use the z's. Then we can cross multiply, divide by 6, and then take the inverse sign. Entering this into the calculator, we get 39.340 degrees. Remember that we want to do easy calculations first, and now that we have two angles, the third angle is easy to find. I just entered into my calculator 180 minus 25 minus, and I use the answer feature so that we don't wind up with a rounding error. And the third angle is 115.660. Now that we have angle y, we can use the law of sines to find side y. When I write out this proportion, I'll use the letter y for angle y that we just found to remind myself to use the answer feature so that we don't have a rounding problem. Cross multiplying and solving for y, we get y equals 6 sine of angle y over sine of 25, which gives us y equals 12.797. And now we've solved for the whole triangle. But wait, remember that when we're solving for an angle in the law of sines, that not only is the angle that we found with the calculator in a solution, but also the supplement is a solution. So we can go back to angle Z that we found at the beginning and find its supplement, which would also be a solution. To do this easily on your calculator without a rounding error, I'm going to type in 180 minus, and then I'm going to cursor up to that previous calculation that we did, sine inverse of 9 sine 25 over 6, and press enter. And press enter, and it's going to insert it in the place after the minus sign, which gives us 140.660. When we solve an SSA case triangle, we'll always assume that there is a second solution. Next, since we found the second angle of the triangle, angle Z, let's go ahead and find the third angle. To find the third angle, we'll take 180 minus 25, the angle that was given, minus angle Z, which we just found, the new solution, the second solution, and I'm using the answer feature to do that, and that gives us a third angle, angle Y, of 14.340. The last side is found precisely the same way we did when we found the first solution. So we have 6 sine Y over sine of 25, but we now need to use the new angle y. So I'll use the answer feature for that. And that will give us a value for y of 3.516. Now it's important to realize that the group of measures on the left represent the first solution, and the group of measures on the right represent the second solution. When you're doing an SSA case, we're always going to start with that first angle and then let the other measures be found using it. Notice that the two angle y's are not supplements of each other, only the two angle z's. All right, that concludes the first video. On the next page, we'll cover that with a second video.